We're going to finish up talking about Chapter 19 by first showing you how the graphing calculator can calculate confidence intervals for you. Now let me start by saying that this is only to be used to check your answers. This is not an acceptable thing to use in place of all of the work we've been doing. But when you're taking your test and you want to make sure you did it correct, this is 100% fine to use just to make sure that you did your work accurately. So to use the calculator, if you have your own graphing calculator, you might want to pull it out now. Otherwise, this is something you can practice in class. You press the stats button, and then if you arrow twice, you're going to arrow over to the tests menu. You're going to arrow down. Now my calculator, it showed as option A. I hope yours does as well, but you're looking for this right here. 1 proportion Z interval. When you press enter, it's going to prompt you for some information. The first thing it needs is the number of successes. This was like when you did your when you checked your conditions. This was the NP hat part. If for some reason when you checked your conditions and you did NP hat, if it was not a whole number, simply round to the nearest whole number because it must be a whole number. So put in your number of successes, N is your sample size, and then you're going to put in your confidence level, and you simply leave it also as a whole number. So 95% would be 95, 90% would be 90. Then you arrow down to calculate, and you press enter. Your answer, they'll have several things on your paper. It should have an interval that looks like this with your low and your high. It should also have your P hat below it, and it should also tell you what N is. But this part right here is the actual answer part that you should be able to compare what you did by hand with what the calculator spit out. So we're going to go through one run by ourselves. So if you have a calculator, I highly encourage you to try it. We're actually going to redo one of the examples we did last lesson. This was the example about the direct mailing, the junk mail one, and they send it to thousands of potential customers in the hope that someone will buy the company's product. So the acceptance rate is usually quite low. Suppose a company wants to test the response to a new flyer and sends it to 1,000 people randomly selected from their mailing list of over 200,000. They get orders from 123 of the recipients. Use the calculator to create a 90% confidence interval for the percentage of people the company contacts who may want to buy. So some info. So our X value is the number of successes. In other words, it's the number of people that order. So that would be the 123. Our N is the number in the sample. That's your 1,000. And 90% is your confidence interval. So let's take a look at the steps you need to go through to use the calculator. So you should have pressed the stats button. You should have arrowed over to tests. And you should have selected 1 proportion Z interval, which again I believe is option A. Or at least it is on my calculator. Your X, when you did your NP hat, you should have gotten 123, which is what we said in the word problem. For N, you should have had 1,000. For your confidence level, you should have gotten 90, and then you arrow down to calculate and you press enter. Now, when I did that, this is what my calculator spit out. 0.10592, comma, 0.14008. And so, if you look back, it was example 11 from the previous lesson. If you look, we ended up with 0.107 and 0.139. So ours are slightly off. Again, we did some rounding in the process. Your calculator has the ability to be a little more specific. So, but that shows that our answer that we found on example 11 was accurate. So this is again something you're more than welcome to use to check your answers, but this does not replace the showing of work. So, the last lesson in chapter 15 is actually learning how to work backwards, how to find the sample size needed to give specific results. We only have 3 examples to look at. They are all the same process. It's just to learn what we're supposed to be going through. So let's take a look at an example. The fox News poll, which estimates that 82% of all voters believe global warming exists, had a margin of error of 3%. Suppose an environmental group planning a follow-up survey of voters' opinions on global warming wants to determine a 95% confidence interval with a margin of error of no more than plus or minus 2%. How large a sample do they need? So I want to refer back to the margin of error formula that we learned. Margin of error was always found by taking your Z star number times your standard error, which was the square root of P hat, Q hat divided by N. And so all that's happening is before we knew everything on the right side and we were just simply typing the calculator to find the margin of error. Now we know the margin of error and we do not know the sample size. We don't know N. And so we're going to plug in everything we do know and we're going to work backwards. One important thing that I want you to jot down, no calculator until the end. In other words, don't touch your calculator for any reason until N is by itself and you're ready to type it in the calculator. So what do we know here? We know the margin of error we now want to drop to 2%. So I'm going to change that to a decimal, 0.02. Z star comes from your confidence level of 95%. And if you remember, Z star was 1.96. And then times, so we got the square root. Now P hat is 82%, so 0.82, times Q hat is the leftovers, which is 0.18, divided by N, which we don't know. So I'm just going to kind of break down step by step the easiest way to get to N. We're going to peel away the layers. The first layer is this 1.96, so we're going to start by dividing both sides by 1.96. Again, no calculator. So we have 0.02 divided by 1.96 equals the square root of 0.82 times 0.18 divided by N. So what's the next piece here that we need to peel away? Well, that would be the square root. Well, how do we get rid of square roots? We square both sides. Notice I'm using parentheses because I want to square all of it. So we now have 0.02 divided by 1.96 squared equals 0.82 times 0.18 divided by N. Well, unfortunately at this point there's not an easy piece to move. We need N by itself, but the problem is N is in the denominator. So I'm going to start by getting N out of the denominator. So I'm going to multiply by N on both sides. That cancels those. That leaves me with N times 0.02 divided by 1.96 squared equals 0.82 times 0.18. Well, now there's only one thing left to get N by itself. We have to get rid of this fraction mess. Well, the easiest way to get rid of a fraction is actually to use the reciprocal. So I'm going to multiply by 1.96 divided by 0.02 squared. That'll cancel on that side. And we're also going to multiply by 1.96 divided by 0.02 squared on that side. So N equals 0.82 times 0.18 times 1.96 divided by 0.02 squared. Now is when you can actually pick up your calculator and type all of this in at one time. And because this is a sample size, these are people, that means that whole numbers are expected. So now is when you put in the calculator all at one time and then you round to the nearest whole number. And so I end up with, if I round appropriately to the nearest whole number, I end up with 1,418 people. So that would be your appropriate sample size. So it's just a matter, in this exact same math we're going to do on every example. So now that we've done it once, the concept is the same every time. So let's take a look at this example. A credit card company is about to send a mailing to test the market for a new credit card. From that sample, they want to estimate the true proportion of people who will sign up for the card nationwide. A pilot study suggests that about 0.5% of the people, so there's your p hat, receiving the offer will accept it. And they want to have a margin of error of 0.1% with a 95% confidence level. How big does the test mailing have to be? So our formula starts with margin of error. So our margin of error, and this is where sometimes we like to make mistakes. Don't forget, this is a percent. So we still need to divide this by 100 to change it to a decimal. So that's 0.001 equals 95%, we already know is a z-star of 1.96. And then we got our square root. Now again, also same thing here. Divide this by 100 and you get 0.005. And if you take 100% minus 0.5%, you get 0.995 divided by n. So we're going to follow the exact same steps I did in the last problem. We're going to start by dividing both sides by 1.96. So that leaves us with 0.001 divided by 1.96 equals square root 0.005 times 0.995 divided by n. What was the next thing I did on the previous example? I squared both sides, remembering parentheses. So 0.001 divided by 1.96 parentheses squared equals 0.005 times 0.995 divided by n. If you remember, the next thing I did was I multiplied both sides by n. So I had n times 0.001 divided by 1.96 squared equals 0.005 times 0.995. And if you remember, the last thing we do is we use the reciprocal. So I'm going to multiply this side by 1.96 divided by 0.001 squared to cancel that. And this side I'm going to multiply by 1.96 divided by 0.001 squared. And so when you type in the calculator, you're going to type in 0.005 times 0.995 times 1.96 divided by 0.001 squared. So go ahead. After you've typed all of that in and round to the nearest whole number, I got 19,112 because it rounds up. And hopefully you got that same answer as well. So let's look at the last example. During routine screening, a doctor's office notices that 22% of our adult patients show higher than normal levels of glucose in their blood, a possible warning signal for diabetes. Hearing this, some medical researchers decided to conduct a large-scale study hoping to estimate the proportion to within 4%, there's your margin of error, with a 98% confidence. How many randomly selected adults must they test? Well, we're not quite ready to go through the process because we don't know the z-star for 98. So I'm going to do some little side work over here. So 98% is this middle area. So we need to take 100 minus 98 divided by 2. And so that actually leaves you with 1%, which when you turn it into a decimal is 0.01, and then of course followed by 2 zeros. So pick up your blue sheet and you're looking on the, again, the negative side, and you're looking for 0.0100, and the thing that I'm seeing closest to it is 0.0099, which is really, really close. So I'm going to use that, which if you look to the left, or I'm sorry, to the right and up, I get negative 2.33. But we're going to drop the negative, so it's just z-star is 2.33. So now that I have my z-star score for 98%, now I can go back to what I was doing. So my margin of error is 4%, so 0.04 equals, my z-star is 2.33, square root, my p-hat is 22%, so 0.22, times the leftovers from 100% are 0.78, divided by n, which I don't know. So now we're going to start by dividing both sides by 2.33. So I have 0.04 divided by 2.33 equals my big square root guy, 22.78 and n. I now have to square the right, put the left in parentheses with a squared. So I have 0.04 divided by 2.33 in parentheses squared equals 0.22 times 0.78 divided by n. Multiply both sides by n. So that leaves me with n times 0.04 divided by 2.33 squared equals 0.22. Whoa, that looks terrible. Sorry. Divided by 0.22 times 0.78. And last step is the reciprocal. So 2.33 over 0.04 squared on both sides. And let's see what we get for n. So go ahead and pick up your calculators and type all of that in, and then round to the nearest whole number. And this time it doesn't round, you don't need to round up. I get 582 people. So this is one that we had used our skills from the previous lesson to find our critical value, because we didn't know 98%, and then we went through the same steps as the previous two examples. And that is the end of chapter 19.